This is an instructional video on dilations. A dilation means to shrink or stretch. And we're working with shapes on a coordinate plane. So we're going to shrink or we're going to stretch a shape. Shrinking a shape means to make it smaller. And this is going to use fractions. Stretching a shape means that you're going to make that shape larger. And this is going to use whole numbers. In order to shrink or stretch a shape on the coordinate plane, we are going to multiply all coordinate points by the scale factor. The scale factor is the number you're using to change the shape. So for this first problem, we have triangle RST, which is graphed for you. And it says vertices are at R, -5, 1, S, -3, 4, and T, 2, -1. The K equals 2 is our scale factor. And so we're going to multiply all of the points by 2. So for R, we're going to multiply -5 times 2 to get -10. And then 1 times 2 to get 2. So R prime is going to be -10, 2. And we can go ahead and graph that as well. We start at the origin in the middle at 0. We go over to -10 and up to +2. And we label that point R prime. We do the same thing to point S. S is at -3, 4. So I'm going to multiply my -3 by 2, the scale factor, to get -6. And then 4 times 2 to get 8. S prime is at -6, 8. We go over to -6 and up to +8. Plot the point and label that point S prime. And the last point T, we're going to multiply both numbers, 2 and -1, by the scale factor 2. 2 times 2 is 4. -1 times 2 is -2. T prime is at 4, -2. We're going to go over to +4, down to -2, put our point and label it T prime. Once you connect your dots, you should have the same triangle, simply larger, because it is a whole number, so we made the shape larger. For this problem, we have rectangle ABCD with vertices A, -3, 0, B, 1, 2, C, 2, 0, and D, -2, -2. And our scale factor is going to be K equals 3. Sometimes they may use a different letter, like M, or any variable that can be represented by a letter, but the number is always going to be what we use to multiply. So for A, -3 times 3 is -9, and 0 times 3 is still 0. A prime is at -9, 0. We start at the origin and we go over to -9, and we stay on the 0 line and label it A prime. B, 1, 2, we're going to multiply by 3. 1 times 3 is 3, 2 times 3 is 6. B prime is at 3, 6. We go over 3, up 6, and we're going to label that problem B prime. For C, we're going to multiply. 2 times 3 is 6, 0 times 3 is 0. C prime is at 6, 0. We're going to go over to positive 6 and stay on the 0 line and label it C prime. And then for D, negative 2 times 3 is negative 6. Negative 2 times 3 is negative 6. So that is our new point, negative 6, negative 6. To graph it, we start at the origin and go over to negative 6 and down to negative 6. Put our point, label it D prime. Connecting the dots, we have the same rectangle. The points are in the same order. It's simply larger. For this problem, we have rhombus JKLM with vertices J at negative 10, 2, K at negative 2, 8, L at 6, 2, and M at negative 2, negative 4. Our scale factor is going to be 1/2. Because we have a fraction as a scale factor, that means that our shape is going to get smaller. The examples we've done so far have been whole numbers, and we made this shape larger. We're still going to take our points and multiply. So negative 10 times 1/2 is going to give us negative 5. Half of 2 is going to give us 1. So J prime is at negative 5, 1. To graph the point, we start at the origin at 0. We go over to negative 5 and up to positive 1 and label the point J prime. For K, we're going to do half. Half of negative 2 is negative 1. Half of 8 is 4. K prime is at negative 1, 4. To graph it, start at the origin, go over to negative 1, up to positive 4, and label the point K prime. For L, we're going to do half of 6, which is 3, half of 2, which is 1. To graph it, start at the origin, go over to positive 3 and up to positive 1, label the point L prime. And the last point M, half of negative 2 is negative 1, half of negative 4 is negative 2. To graph it, we go over to negative 1, down to negative 2, label the point M prime. When you connect the dots, you should have the same shape, simply smaller. For this problem, we have triangle WXY with vertices W at negative 4, 8, X at 10, 0, and Y at negative 2, negative 8. For this problem, our scale factor is 1/4. So again, our shape is going to be getting smaller. We're going to take each point and we're going to multiply by 1/4. Negative 4 and 1/4 is going to give us negative 1. 8 and 1/4 is going to give us 2. To graph it, we start at 0. We go over to negative 1, up to positive 2, and put our point, labeling it W prime. For X, we're going to take 10 and we're going to multiply it by 1/4. And we're going to get 2 and 1/2. And then we're going to do 1/4 times 0, which is going to give us 0. To graph a fraction, we start at the origin, I go over to 2, and then I go the 1/2 length, which is going to put me here in the middle. My y value is 0, so it's going to stay on the that x-axis. And I label it x prime. For y, we're going to do negative 2 times 1/4, which is going to get me negative 1/2, and negative 8 times 1/4, which is negative 2. Again, to graph it, we start at the origin. I go over to negative 1/2, which is going to be about there, and then I go down to negative 2, which puts my point here in the middle of the negative 2 section. And we label it y prime. We connect the dots, and we have the same triangle, but slightly smaller. For this problem, we have square DEFG with vertices D, 0, 0, E, 2, 4, F, 6, 2, and G, 4, negative 2. And we have our scale factor, which is 5/2. Some of the fractions can start to get complicated, so you can use your calculator to help you on that. That is totally fine. We're going to start with point D. 0, 0. 0 times 5 over 2 is 0, and 0 times 5 over 2 is still 0. So point D prime is going to stay the same at 0, 0. Notice how on this graph our y-axis and the x-axis are not in the middle. They have shifted them over in order to fit the shape on the new graph. For point E, we're going to multiply 2 times 5 over 2, and we're going to get 5. And then 4 times 5 over 2, which is going to give us 10. E prime is at 5, 10. When we graph it, we go over to 5, and then up to 10. And we're going to label that point E prime. For F, we're going to multiply 6 times 5 over 2 to get 15. And then 2 times 5 over 2 to get 5. F is at 15, 5. So we start by going over to 15, and we're going to go up to positive 5. And we label that point F prime. For G, we multiply 4 times 5 over 2, and we get 10. And we get negative 2 times 5 over 2, which is negative 5. So we start by going over to positive 10. And we're going to go down to negative 5. And we label that point G prime. When we connect our dots, we end up with the same square, but larger. Now, I know what you're thinking. Even though that this was a fraction, the shape got larger. And I told you that fractions were to make a shape smaller. However, 5 over 2 is an improper fraction. That is really 2 1/2. And so we have a whole number 2 and then the fraction. So that's why the shape got larger, even though the fraction was used as the scale factor. For this problem, we have triangle STU with vertices S, negative 15, negative 3, T, negative 12, negative 15, and U, 0, negative 9. Our scale factor is 1/3. Notice again how they have shifted the origin of our graph in order to make the shape fit. For this problem, we're going to multiply all of our points by the scale factor negative 1/3. So starting with S, negative 15 times 1/3 is going to give us a negative 5. Negative 3 times 1/3 is going to be negative 1. To graph it, we go over to negative 5, down to negative 1, and label our point S prime. For T, we do negative 12 times 1/3, which is going to give us a negative 4. And negative 15 times 1/3, which is negative 5. To graph the point, we go over to negative 4, down to negative 5, plot the point and label it T prime. For U, we multiply 0 times 1/3 to get 0, and negative 9 times 1/3 to get negative 3. We start at 0 and we go down to negative 3 and plot the point U prime. Connect the dots and we have the same triangle, slightly smaller. For this problem, we have quadrilateral ABCD with vertices A at negative 4, 1, B at negative 2, 3, and C, 0, negative 2, and D, negative 5, negative 2. Our scale factor is going to be 3, meaning our shape is going to get larger. Starting with point A, I'm going to do negative 4 times 3 to get negative 12, and 1 times 3 to get 3. Again, they have shifted our coordinate plane, so our origin is down here. We count over to negative 12, and we go up to positive 3, and plot our point A prime. For B, we're going to multiply negative 2 times 3 to get negative 6, and 3 times 3 to get 9. We start at the origin and go over to negative 6, up to positive 9, and label that point B prime. For C, we're going to multiply 0 times 3, which is 0, negative 2 times 3, which is negative 6. So we start at 0, we go down to negative 6, and label that point C prime. And for D, we're going to multiply negative 5 times 3 to get negative 15, negative 2 times 3 to get negative 6. We start at the origin and we go over to negative 15, down to negative 6, and plot the point D prime. Once we connect our dots, we should have the same quadrilateral, but slightly larger. For this last problem, we have triangle LMN with vertices L at 2, negative 8, M at 12, 8, and N at 14, negative 4. We're going to use our scale factor, which is going to be 1/2, meaning our shape is going to get smaller. For now, they have moved our origin over to this left-hand side in the middle, so that way the shape will completely fit on the coordinate plane. To start with L, 2 times 1/2 is 1. Negative 8 times 1/2 is negative 4. Starting at the origin, we go over to positive 1 and down to negative 4 and put our point labeled L prime. For M, 12 times 1/2 is 6. 8 times 1/2 is 4. So we're going to start by going over to positive 6 and up to positive 4. And we're going to label that point M prime. And for the last point, 14 times 1/2 is 7. Negative 4 times 1/2 is negative 2. We go over to positive 7 and down to negative 2, labeling that point N prime. Connecting the dots, we have the same triangle, only slightly smaller.